All right, so one last problem for this lesson. All right, so we looked at just charges and charge densities and stuff like that in the previous two. We just used one block, basically this block here. So we used this block and we said, okay, well, what is its, how many electrons are left over right after it's charged, right? And we've lost these electrons. How many electrons did we lose actually? And then we looked at the charge density on that block. Now what I want to do is I want to take the situation where I have these two blocks. One's larger than the other, but they both have the same charge, 10 microcoulombs, plus 10 microcoulombs. Then I'm going to bring them together, and I'll let the charges equilibrate. That's going to happen really fast, so I don't have to really worry about how long it takes. So that rather than just this having one charge density and this having one charge density together, they have the same charge density, which is going to be somewhere in between those two. And then we pull them apart, and at that point, they're going to have different charge densities than before. So they're each going to have the same charge density that they had here in step 2 in step 3, so that basically all the charge that's on this one in step 2 goes this way, and all the charge that's on this one on step 2 goes over here. And so, because this has a larger area, and it has the same charge density as this guy, what's going to happen is this is going to have a larger charge than this one. So what we're going to go through and do is first we're going to find this charge density here, and then we're going to go back and pull this apart there. Now there's nothing different about this than what we did in the last one, right? So if we want to find that charge density, d bar 2, that average charge density, we'll just add the charge on both of these, the charge of this and the charge of that, and divide by the surface area of both of these two guys, the area of this and the area of that, which is just 6 times the area of one of the faces. Remember, we talked about that before. It's a cube, it has 6 faces. Those 6 faces make up the surface, so the area of those 6 faces together, 6 times whatever that was, is the total area. So that's going to be 10 microcoulombs plus 10 microcoulombs over 6 times 0.01 meters squared plus 6 times 0.02 meters squared. That's supposed to be a 2. So 10 plus 10 is 20. A micro is a 10 to the minus 6 coulombs over, okay, so these are 10 to the minus 4s. So we have 6 times 1 times 10 to the minus 4, and 6 times 4 times 10 to the minus 4. So that's 6 plus 24 times 10 to the minus 4 square meters. All right, so that's 30. Right, so this thing here is 30. And I can cancel out a 0 there, so I end up with 2/3. 10 to the minus 6 plus 4 is 2 times 10 to the minus 2 coulombs per meter squared as that charge density. So that's 6.67 millicoulombs per meter squared as the charge density. All right, so over those two different guys, less than the 16.7, I think it was, millicoulombs per meter squared from the previous example. All right, so, and it should be less because this guy has like 1/4 the charge density of this guy. So when you add them together, it should be less than this and more than 1/4 of the last one and less than the full amount. Okay, so there that is right there. And that should be, I don't have another error, do I? Let's see. No, that's right. That's a millicoulomb. All right. All right, so Now we need to find the total charge of each one, and actually that's not too difficult. So all you're doing there is doing Q1 is equal to the density, the D2 bar, times the area, which we said was this 2/3 times 10 to the minus 2 coulombs per meter squared. And the area we said was 6 times 10 to the minus 4 meters squared for this guy here, or for this guy now. They're the same guy, but different times. So we have 6 times divided by 3, which is 2, right? So that we have 4. And then we have 10 to the minus 2 times 10 to the minus 6, which is 10 to the minus 6. The meters squared cancel, so we just have coulombs. So we have 4 microcoulombs for this guy. Now, I think I'm running out of room here for Q2. Of course, I'm running out of room, so I do the biggest thing. So I guess that's A2. We have the same charge density, but the area is 4 times as large. So actually, we have D2A1 times 4, which is 4 times this, which is 16 microcoulombs. All right. So that seems simple enough. So to go through this one, we end up with a fairly simple procedure. First, we take these two guys, we add their charges to get 20 microcoulombs, then add their areas down here to get about 30, or about 30 times 10 to the minus 4 meters squared. Let's see, so that is 30 centimeters squared, which is fine. And we end up with our 6.67 millicoulombs per meter squared as our density. And finding the density then allows us to find what the charges on these things are after, right? So here they're separate, but when they come into contact, they equilibrate so that they have the same amount of charge in each spot. And when they're brought apart, they each have the amount of charge that they had previously there. Not too horrible, I hope. So that's enough for lesson 1. I think I've already got lesson 2 online, so we'll do the lesson 3s right after this. All right?